Okay, and just in case you're wondering, for completeness sake, this is a schematic basically of the circuit I built. So the only exceptions are that these two input output capacitors are way smaller, because these are all I need for like a sub 40 hertz response on the input and output. So 200 nanofarad and 100 nanofarad, and that's it. So I didn't need these big values. I just wanted to make sure it was overkill. I can't help but wonder if that's responsible for that weird spike at about 9 megahertz or so, because it's strange, how that happened. Yeah, see that spike there, because like I said, you can take this thing and, it's in V peak mode right now. So, it's about 1.7 volt, 2.1 volts that source actually rose up to. And I tested on the scope and it does the same thing. Whereas nominally, it's at about 80 or 90 millivolts. But yeah, right there, that's just anomalous. It makes me wonder if the power supply was bleeding through on that, because it isn't a big electrolytic, and if it was reverse biased, it can act like a short circuit, and it could damage your equipment. If that's true, I'm just really not sure. It's anomalous because I've never seen that, despite all the analysis I've run with this particular tool on amplifiers. But at any rate, it didn't appear to do any damage as far as I can tell. I mean, it's still running. And this is a square wave. You can see it's pretty heavily distorted for, at 130 kilohertz. So, know what that's about. Because it's got a lot of distortion in it. But this, the data sheets on this transistor actually, because it's actually an RF JFET, and they actually carry it out, to like 1 gigahertz on the data sheets. They actually have data going out to 1 gigahertz on this thing. So, so anyway, but there's a lot of things on a breadboard or whatever that can go wrong. But anyway, that is the, that's the circuit. But yeah, like I said, so you can, do, let's see. Oh, I'm in the wrong thing. But yeah, you can, not just do, voltage, but you can do RMS voltage. So, you can see, and anytime you change a scale, you got to go set it, to whatever range you're looking at. But yeah, you can see, what's going on here, so, these various ranges, you can do percentages, you can do, gain like we were doing before, but again, you got to adjust your range. And like I said, always make sure your source is right. And you can also do it decibels. So, so you can see there's quite an increase, like what, 13 decibel gain on it. So, it's probably 5 times or so, increase, above its baseline. That's pretty tripped out that it starts to gain like that. Again, I've never seen this do this. I've always seen it roll off at higher frequencies, but I've never seen it actually increase. That's strange. So, but it does do that when you do it on the scope too. It's harder to see here. I got the scale set differently. If I take them both to 1 volt per division, make adjustments in the frequency. Here you can kind of see, let's see, we're at, I got 20 megahertz right now, but, right around 10 megahertz or so, it starts to do funny things, so I'm not really sure what the reason that is. It's so squirrely. But at any rate, so I just wanted to kind of conclude that, for this series on JFETs for now.